Today I'm going to teach you about something called vertical angles. But before I actually tell you what those are, let's take a look at this proof together. We've done something similar. So of course you're going to start with your given. And we know that the next thing that we usually say when we're given the diagram as shown is that we have some straight angles. So I'm seeing two straight angles in our diagram. I'm seeing angle ABC and angle DBE. So I'm going to go ahead and state that both of those are straight angles. My reason for both is assumed from diagram. After straight angles, we usually talk about supplementary angles. So I'll go ahead and say that angle 1 is supplementary to angle 2, and angle 2 is supplementary to angle 3. The reason for both of these is if two adjacent angles add to a straight angle, then they are supplementary. So far, this proof is exactly like we've done at the beginning of this chapter. Now, hopefully you're recognizing that we've got angle 2 twice, so we're able to say that angle 1 is congruent to angle 3, because if two angles are supplementary to the same angle, then they are congruent to each other. Now I'm actually going to teach you a way to do this problem in just 2 steps. By the end of today, you're going to be able to just say, step number 1, given. Step number 2, angle 1 is congruent to angle 3 because vertical angles are congruent. Now let me teach you what vertical angles are. We have something called opposite rays. Opposite rays are two collinear rays that have a common endpoint and extend in different directions. So in our picture to the right, we've got ray BC and ray BA that are opposite rays. They have a common endpoint, point B, and they're going opposite rays. Ray BC is going to the right, ray BA is going to the left. But yet they're still collinear. They're still part of the same line. So let's look at why some of these are not opposite rays. Ray KJ, and ray LM are not opposite rays because they have no common endpoint. You could also consider that they may or may not be collinear. We don't know because they're not drawn as part of the same line. In the next picture, ray PO and ray QR again have no common endpoint. So why are opposite rays so important anyway? Well, they help us define vertical angles. Vertical angles are formed whenever two lines intersect. If the rays forming the sides of one angle and the rays forming the sides of the other angle are opposite rays. Now the most important part of all of this is our theorem. You're going to like this one. We don't even need an if-then. We can just say vertical angles are congruent. In our picture, which ones are vertical angles? It's the ones that are across from each other. So angle 1 and angle 3 are vertical angles, and angle 2 and angle 4 are vertical angles. Okay, so let's go ahead and see what this looks like in a proof. Just like always, we start with our given and angle 4 complementary to angle 2. Now, here's where we want to look at our picture. What else can we learn from the picture? This time, we can see that angle 2 and angle 3 are vertical angles. In our proof, we don't need to say that they are vertical angles, we're just going to say the result. Angle 2 is congruent to angle 3, that's the statement. The reason is vertical angles are congruent. Now, we're ready for our step 4, which is that angle 1 is congruent to angle 4, because if angle 2 and 3 are congruent, and 1 and 4 are complementary to those, we can use the theorems we learned at the beginning of this chapter. If two angles are complementary to congruent angles, then they are congruent to each other. Lastly, let's look at a solving problem involving vertical angles. Since we know vertical angles are congruent, we don't have to be told that in the given anymore. We can just go ahead and say, okay, these two angles are vertical angles, so I'm going to set up an equation where I set them equal. This is a little bit tougher problem to solve because you've got an x squared and an x, so I want to move everything to one side, combining like terms as I go, and I'm going to have to factor. Unfortunately, this one's not going to even factor. So what I'm left with is doing something like the quadratic formula. Yes, the big QF. So, in case you forgot, here's what it says. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. When we simplify that, this is what we've got. Negative 6.5 squared is 42.25. Negative and negative is going to be plus 168 over 2. The square root of that gives you plus or minus 14.5. So our two answers are x equals 10.5 or -4. Now, of course, we're still not done because this is geometry, not just algebra. Now we've got to actually plug that answer in. So, when I plug it in to find angle 1, I'm going to start with the 10.5. When I plug it in, I don't know what angle 1 is, but I'm going to choose this one on this side. This looks a little bit easier to me. So when I plug it in, I get 47.25. When I plug in -4, I get 40 degrees. Now I'm still not done because that's just finding this angle right here. I need to find angle 1, but I can see from my picture that these two angles are supplementary. So to find angle 1, I'm going to take what I got for that angle and subtract it from 180. So I either get angle 1 is 132.75 or 180 minus 40, which is 140 degrees. Alright, that concludes the lesson for today. Good luck on the homework.